Hey kiddos, so we have Unit 1, Lesson 7, Construction Techniques 5, Squares. All right, so our learning goal is basically we're going to use our straight edge and compass to create some movements that will construct squares. So let's get at it. Warm up 7.1, which one does not belong? Polygons. As you can see, there's several ways you can look at it. There's an argument for each one. For why they don't belong, right? You could talk about their sides, the number of sides they have. You could talk about the length of their sides. You could talk about the angles for the vertices. There's so many aspects to this that you can answer. All right, activity. It's cool to be square. So I want you to follow along with me using GeoGebra and to turn in these constructions that you create on GeoGebra and just turn them into our classroom for Google Classroom for this lesson. So use a straight edge and compass tools to construct a square with segment AB as one of the sides. This one's a bit tricky, but I remember them telling us to use straight edge and compass, which means circles. The only 2 points I'm given is AB, right? So I'm going to go ahead and just create a perpendicular bisector right away. All right, so notice the 2 circles I centered on A and B are the same radius, have the same radius. And I want to go ahead and create my perpendicular bisector now. So let's get that point of intersection. There we go. Let's get this point of intersection. There we go. There's the perpendicular bisector. Now, how else can I do this where I can construct this square? Well, I'm going to keep using circles because I have 2 new points, right, that I can work with. In fact, I actually have 3. I have this middle one right here, right, the midpoint of AB. And I'll make a smaller circle with the diameter of AB. Now, why do I need to do that? Well, we know squares have all the same sides, right? So what better way to represent the length of our side by using that size of a circle, right? Because AB is now the diameter of that smaller circle. And I'll go ahead and keep going. I'm going to create another size circle, same radius, okay? Because what's happening now is I know that 2 radiuses make a diameter. So I'm going to be using that to kind of make my future movements. I'm going to use another circle. I hope this is my last one. And as you can see, I kind of messed up on my mouse a little bit. I have this intersection here, and I'll make the same radius. Now, I'm trying to look here, and I notice this. I notice this point as well. All right. So I think I did it. I think this is the square. So hopefully you're following along with me using GeoGebra. All right, build that confidence up. And as you can see, I'm just creating line segments to create my square with the side of AB. Now, to double check, I know the lengths all have to be the same, right? Well, if you look, these 2 points, these 2 vertices, have the same radius in terms of A. So that's how I know for a fact that this is a square. You could even test the other points if you're not sure. All right, so here's AB, all right, and then even this one from B to this point up here, same radius. All right, it's a great way to double check. You can even do the point up here if you really wanted to double check your square. See, all those circles are the same radius. Okay. All right, and I think that was their hint. So hopefully you follow along with me on that in GeoGebra. All right, here's the main activity for the day, trying 7.3, trying to circle a square. So here's some steps that I want you to follow along with me. You can create this using GeoGebra if you want. But the main idea here is to follow these instructions. So I want you to kind of watch as I follow through these instructions with the given shape. So they tell us right away it's a square, all right, with a diagonal of BD. Awesome. First part, construct a circle centered at A with a radius of AD. So circle centered at A with a radius of AD. Okay. Second step, they asked us to do the same thing except on C with a radius of CD. So go to C, radius CD. Then they say draw a diagonal AC to write a conjecture about the relationship between the diagonals BD and AC. Ooh, this is an important one. So let's draw the diagonal of AC. And they say write a conjecture about the relationship between BD and AC. So those are the two diagonals. So what conjecture can we make? What can we assume using what given information we have to say that they are have a certain relationship? All right, so do you agree that AC is the same length as BD? Would that be reasonable, and why? Okay, so part D, label the intersection of diagonals as point E. Intersection of the diagonals as point E. So we got a center point right here. We'll call that point E. And construct a circle centered at E with a radius of EB. Okay, so here's my circle, centered at E, but the radius has to be from E to B. How are the diagonals related in the circle? So these diagonals are what in reference to that circle that we just created? All right, so hopefully you thought about it, you paused the video, and you kind of were like, okay, what is that? You know, what do the diagonals have to do with the radius or with the circle? And my Freudian slip there was kind of leading into the idea that EB is the radius for the entire circle that we just created all the way around, right? So AE, DE, CE, BE, they're all the same length, right? So AC is going to be the same length as BD because, well, those are the diameters for the same circle, all right? Last but not least, I believe, use a conjecture and a straight edge and compass move to construct a square inscribed in a circle. Boy, I'm going to have to draw a line through this circle. So I'll use the center here, make sure it goes through the center, and I'll just pick a random point. All right, I picked it right there. You could pick it somewhere else if you want. I want to create another circle, this time from here to over here. And then I'm going to do the same thing except center it over here. And then the radius goes all the way across to give me that eye looking like construction. Now, what I'm really doing is I'm just creating a perpendicular bisector, right? And I'm trying to get it, there we go. So there's my perpendicular bisector. Now, do you see those new points of intersection right here and right here? What happens when you connect line segments between those points? What image or shape did we construct just now using perpendicular bisector? A square. All right, so hopefully you followed along with me in GeoGebra. It's really important that you do that. Our summary for squares. So just to kind of reiterate, we know that using perpendicular lines and congruent segments to construct different objects, right? We just did that with the square, right? It's made up of 4 congruent segments that create 4 right angles, 90-degree angles. A square is an example of a regular polygon. Since it's equilateral, all sides are congruent. All right, so as you can see, inscribing a polygon inside a circle ensures that all your sides are equilateral. So as long as the vertices of whatever your polygon is are on the edge of the actual circle, all the sides could be equilateral, all right, if you construct it correctly. All right, I believe that's it for the lesson. Have a wonderful day. Make sure to complete your classwork, by the way, for assessments.